Jai Jirendra, Namaste and welcome to my channel. Today we are going to solve the 52nd question of the problem solving series and the fourth and the last question of Q data structure. So the difficulty level for this question is hard, and this question has been asked in multiple companies: Microsoft, Amazon, Google, Facebook, Goldman Sachs. Okay, and yeah, so let's look at the example. Sliding window maximum. Okay, so we are given a nums array, okay, list of integers, and we are given a sliding window constraint, that is k, that is 3, right? So we need to find the maximum value in this constraint. This is like a sliding window, it keeps moving one step ahead every time, right? So when this window is in this 3 size at the beginning, so 3 is the length in this example, right? So k is this variable, so here k is 3, so we take these three numbers and we find the maximum. Okay, so we need to return a vector of int for each sliding window. We will be returning the maximum value. What is the maximum number in this window, right? So you can see in this window the maximum number is 3, right? So 1 3 minus 1 3 is the maximum. So the first value of the returned vector will be 3, and then this window will go ahead and we will move from left to right, and the window will contain the number says 3 minus 1 minus 3. So still the max will be 3. Then we will go with minus 1, minus 3 and 5. So now we have moved ahead, and earlier our max was 3, but now since we have moved ahead, we don't have 3, we have a new number 5. So minus 1, minus 3, minus 5, in these 3 numbers, 5 is the maximum, right? So in this way we need to solve this. So then minus 3, 5, 3, still 5, 5, 3, 6, it would be 6 now, and then 3, 6, 7, it would be 7, right? So this would be our answer, right? So yeah, so you can, it might be given that after that, if there are no numbers, we can still, for 6, 7, if we include that, then we can have 7. And for 7 we have 7. Otherwise it also could be that, okay, whatever is the size, if the size in the k goes to the last, we return at that point. So we are taking this case, okay. So this would be our answer. Now how do we solve this? So you have understood the problem statement. So we have this window, right, and we are finding the maximum in the window. So what would be the brute force approach? So we will have 3 numbers. So whatever, any k numbers, we will just find the maximum in that list of numbers, say minus 1, 3, minus 1, and then we'll move ahead and then we'll find the maximum. So it will be continued, right? So in the brute force, I think it's very clear that we can solve this problem in order of n square, right? So moving from left to right one by one and finding the maximum, right? So we are traversing the elements twice, like so we are using a double traverse loop, right? Inner loop. So this is a brute force, and we are very sure till now that this won't work. The interviewer will not be satisfied. He would need a better approach. So now how do we solve this? What would be the intuition, right? So see, we are taking a variable number of the window length, and we need to find the maximum. So in this case, when we are taking 1, 3, minus 1, right, we found the maximum as 3, right? But when we move ahead, then we get a new number, and this new number could be greater than the number that we have from this, and it could be smaller as well, right? So how can we optimize this, that in one traversal we get our answer, the answer doesn't changes? What data structure, what technique, what algorithm, what idea should we use to solve this problem, that we find the value in one traversal, or in one go, or we don't need to find the maximum every time, right? Because the numbers are repeating, we are losing one number and then we are getting a new number. So when we are losing one number, is that number important to us? Like here, when we lost, it was 3 minus 1 and minus 3, right? So when we lost this number 3, it was when we moved to the next right? We got a new number 5 and we lost this 3, right? So the value could change, right? So earlier this was our max number. We will have our max number, but now we need to leave that max number. Why? Because if we have a structure where we are storing 3 numbers, and when we get the 4th number, okay, then what can happen? In the 4th number, this we need to leave the first previous number, right? So when 1 3 minus 1 is there, when another number come minus 3, so we need to leave this one, right? And then we need to insert one more. So we need to pop out from the front and we need to insert it into the back, right? So popping out, when we pop out from a data structure and we pop out the last value, right? Last in first out, then it is stack. But here we are popping out the first number, right? So ideally we understand that, okay, Q. We can have a Q and we can keep on popping out whenever the size crosses the K, right? So we got the intuition that, okay, we can use Q data structure instead of array and finding it out every time. We can use a Q data structure and we can push the elements until, and we can find the max in that, and if it crosses the line, we can just pop out the front element, right? If the number in the window crosses K, right? And we can insert now inserting it to the back side, right? So if we are inserting, our window changes, one element goes and the new element comes. So we are popping out from the front and we are pushing it to the back. We need both the things. So for that kind of, so we have a data structure, we have made a data structure which pops out from the front and gets the value in the back. Okay, we can do whatever we want, pop back, push back and pop front. Both operations are possible in a DQ structure. So you can study about this in C++ SQL. So we can have a DQ which helps us to pop out from the front and push it to the back. Okay, and this will help us to optimize this solution, right? And we can have a, let's take a vector to store the result, right? Vector int, say answer, right? Anything, answer. So with the help of DQ, how can we optimize this, right? DQ is a data structure which helps us to pop out from the front, push to the front, pop out from the back, push to the back. Both sides we will have like a pointer and we can do both the things, right? So this structure has been made and this will help us to solve this problem, but how? So you know that in the brute force approach, we were checking every time which is the max. But to get the max in order 1, right, we need to get the max in order of 1 so that the time complexity is become order n, because we are traversing the whole array. We need to traverse the whole array. So how can we find the max value in one traversal, right? So to get that, we need to have it at the front or at the back, because front and the back are the only two things that we can get at order 1 from the DQ, right? Because it has access to both front and the back index, right? So this is one thing. So our target would be keep the maximum element, the maximum valued element at the front of the DQ, so that when we get the next element coming to the window, we can compare, we can find out, okay, like if it is actually greater than all of them, right, then we can insert it into the front, right? Or like we need to do something, like what could be the logic? We need to evaluate these different scenarios. How do you come to the approach? You need to think about all the scenarios, right? You need to look at the examples, make more examples and okay, make your approach, right? Questions may not be repeating, right? So you need, we'll do this. We'll find the problem, a solution to the problem as if we don't know, right? Like layman guy, like normal coding guy, if you see the problem for the first time, what do we do? Like you need to think like this. We'll solve it like this. So when we have the first element, right? So if the first element has come, do we return anything? We return only when the size of the queue is 3, right? Size of the window is 3. So that is one thing. So after that, every time the size of the window would be 3. So we will be we will be returning to the vector, answer vector, only when once this size gets greater than the I becomes greater than I minus k is greater than 0 probably, yeah. So what do we do? So this is one thing, you need to note these things, right? Okay, so when we have 1 we don't have any problem. What do we do? Like, okay, we have 1, let's push it to the cube. Okay, now when we get 3, now when the first element is, that is the max. When 3 comes, 3 becomes actually 3 is the max. Now if we insert this 3 here, we need to like traverse it again, like to find this 3, right? So we will try to keep the 3 in the beginning, right? So what do we do? If this coming element is greater than the last element that is present in the cube, why don't we pop this out? Because we don't need this. Because any other element that would come, we will anyways return the greater element. 1 is not going to be required. So what we will do, if the element that is present at the back of the cube, like you can note these things, if it is going to be less than the element in the cube, the coming element, we will pop it out. We don't need it. We need the max element. Okay. So what do we do? Let me write down the steps one by one. Okay. Let me code it and let me explain you the scenarios. That would be okay, or yeah, that would make more sense. Okay. Otherwise, remembering everything and then coding it again, we will forget it. So we will code each and every observations, and yeah, at the end you will understand the solution. So we will traverse the array. Okay. So what did we understand? We will be returning the answer. That is for sure. Okay, like this. Now, when we return the answer, let's should we go from the bottom? Yeah, we'll go from the bottom, no problem. One thing we sure, when if I minus k is greater than equal to 0, right? 2 minus 3, right? 2 minus 3, or you can say 0, 1, 2, right? So I, or you can say if I is greater than equal to k minus 1, because we are starting from 0, right? So if I is greater than equal to k minus 1, so 0, 1, 2, 3 minus 1, 2 in this example. So we have reached the window. Okay. So every time, so in the beginning only, like first two case we are not reaching, we don't need the answer. In this case we reach, right? So if that is the case, what do? We will push the answer to the vector, right? And what we will push? We'll push the element that is at the front of the queue, right? So we will be storing the address actually to the position of the element in the queue. So we will get the element by like this, dq dot front. Okay. So you might not be understanding the beginning how this has come, how this will give our answer, but you will understand. So this is one's idea, right? dq dot front should be having the max element every time, okay, which should go inside the answer after crossing the size of the window. Okay, so this is one thing. This is one observation we understood. We wrote this. Now the second thing is we need to push the elements to the queue, right? Every time when a new element comes, that has to go to the queue. Okay. So we are reverse engineering it actually. So we will be pushing the new element to the back, because in the front we will have the max element only. Now I'll explain you one thing. dq dot pushback I should be done here. Suppose our queue contains 3 and 5, okay, and now we got another number 7. So firstly our queue won't contain 3 and 5 because the max would be the front. So it would be say 6 and 5, right? Now when 7 comes, that time do we need these elements? Because if 7 is there, 7 can't be at the back. 7 is the biggest one. So we will compare, okay, is it greater than 5? Yes, 7 is greater than 5, right? So we will just remove it. Is it greater than 6? It is greater than 6. So we will remove it. Now Q has become empty and then we pushed it to the Q, right? Because we want the max. Say in the Q it was 9,8 already. 9,8 and then we get 7. Then now 8 is actually greater than 7. And we have a place, right? Means Q can accommodate, right? More than 3 in the window. So we can just actually add 7 because this is lesser. So we will code this part so that our max at the Q remains at the front. So what we have understood? While DQ is not empty, because once it is empty we can't pop it out, right? And nums DQ dot back, so this one, like say 986 if it is there, okay, and 7 comes, okay. So DQ dot back, if it is greater than, is less than numSci, okay. If it is greater than less than numSci, so what do we do? DQ dot pop back, we will pop it out. So what will happen if this is the case, 986, so 6 is less than 7, so we will pop out 6, right? Now 8, again in the back it's 8, 8 is less than 7, no it's not, it is greater than 7, so we will come out of the loop and then we will push this 7 here. That is the last element that has come here. But actually we are going to push the position and then we will get the element from nums, okay. So we need the position. Why do we need the position? We'll understand. Now say, since our DQ is not having all the elements, right? Sometimes we, like here, we are popping out elements, right? We are trying to keep the max element at the beginning. But actually the Q has all the elements. Like Q has got the size together, right? So how I will explain, right? Say, okay. Now say if we have this many elements, 12, 10 and 8, okay. And now 6 comes. So when it comes to this position, 6 will come, 6 and 6 is smaller than this, so 6 we will be over here and we will be returning 12. But already we have 3 elements. How we will check that the size of the Q has exceeded and we need to remove the element that is at the beginning. When the elements are coming in decreasing order, we are pushing it to the Q, we are not popping it out, right? We are popping it out when the elements are in other order, right? Because we don't need them. We need the front elements to be the bigger, right? So when this happens, okay, that point of time we need to pop it from the front, right? We don't need this, you have crossed the limit, right? So to get that part, we have actually inserted the position in the DQ. How we will find out, right? How we will find out? So how we will find out? We'll find out when the Q has crossed, like the front element is actually needs to be removed, right? Because it has crossed the limit of the sliding window. So how do we find? When the Q is not empty, of course. If it is empty, then for sure we don't have any problem. And now, if DQ dot front is equal to I minus k, then we need to pop it out from the front actually, not back. Now how this has solved the issue? For example here, okay, so when this DQ dot front equal to I minus k, so when k is 3 and say I is 0, 1, 2, 3, 4, 5. Okay, it's 5, 3. Every time it is like this, right? Okay, let's take an example. Okay, I'll. This is the only part which needs to be understood. Other than this, everything is clear. So if in the queue we have, this is another example. Okay, where in the queue the elements are 3, 7, 5, 4 and 2. This has come into the queue. So in the beginning when 3 comes, we push it to the queue. Okay. So in the queue we have 3 now. When 7 comes, since 7 is greater than 3, these conditions, we will pop out 3 and we will keep 7. Okay, since the queue is empty now, we will insert 7. Fine. Okay, so 7 is actually not inserted. We inserted the position, right? 0, 1, 2, 3, 4. So 1 has been inserted. Now, when 5 comes, right? 5 is actually less than 7. So we don't have any problem. This condition won't be fulfilled. So we will insert 5. When the next element comes 4, 4 is also less than 5. This condition is not fulfilled. So we will insert 3. Now, right? Anyways, when we need to when we have inserted this 2, our max was actually 7 only, right? When this has crossed, so our answer would be 7 only. When this 4 has come, right? That time also 1, 2, 3, the front element is 7 only. So both times 7 has come, 3, 7, 5, 7, 5, 4. 3, 7, 5, 7, 5, 4. But when it is 5, 4, 2, right? 2 comes. And we see, okay, we have 7 in the queue, 5 in the queue, 4 in the queue, and 2 is actually, this condition is not fulfilled. 2 is actually not greater than 4. So what do we need to do? We, in this example, if this condition is not written, so we will insert this and still our answer would be 7. But that is not right because the window has changed. So what we will check before entering anything to the queue, that okay, see the size of the queue, right? So now here when we come, the DQ is not empty and DQ dot front. So what is in the DQ dot front? 1. Okay, if it is equal to I minus k, what is the value of I? I is 4 and k is 3. So 4 minus 3 is 1. That means this is equal. Then we are popping out the front element, right? This would be front, this would be popped out, and then this 4 would be coming and we will pop out. The answer would be 5, right? So how did this happen? DQ dot front is equal to I minus k. That means I minus k will always be the position of the just next element, right? Just the when the numbers are continuously bigger, like 7, 5, 4, right? So all the elements are there in the queue, right? So the I minus k would be just the previous window, last window. If that order is completely from, I'm not sure if you are understanding or not, if it is coming from increasing to decreasing, we are having all the elements in our DQ, we need to pop out the first element, right? Because it is the first element, right? So 7, 5, 4, we know that 7 is greater element. And if this 2 comes, this needs to be removed. And in the queue we have this, right? So we need to remove it. So this DQ dot front equal to I minus k will help us to remove the largest number in the previous window, right? Because we don't need that. The new element is coming. Though the new element is lesser than that, if we remove it, then this becomes the next greater element in the DQ will be the next element in the window. Okay. So this is simple code. We need to understand these cases, and I hope, since it is a little bit of difficult question, once you understand, it's very easy, right? The link to the question has been given in the description. Please try it yourself and then come to my code walkthrough section. Code walkthrough of the sliding window maximum problem. You can see here in this LeetCode platform, this question is little difficult, and this has been asked in a lot of companies, right? Apple, Adobe, D Shaw as well. Okay, so you can see this example here. The window position k is 3, same example, 1 3 minus 1, the max is 3. Then this window moves from left to right. 3 minus 1 3 is 3, minus 1 3 5 is 5, minus 3 5 3 is 5, and then 5 3 6 is 6. And after 3 6 7, once we reach the last element, the wind, like the k reaches here, we are not going to insert any other elements. Okay, so this will be our answer, 3 3 5 5 6 7. So looking at the code, what I explained already, you can see here we have done the same thing. We are checking here in the first part of the loop that the window is not crossed. The dq dot front, if dq dot front is equal to I minus k, we need to pop the first element from the dq, because they are in increasing order and the next element should come, and we need to remove the front element from the dq. Okay, and then we check this one while dq dot empty. This line helps us to keep our dq in a decreasing order, so that we can get the front element returned as a maximum in the window. Okay, so that's why we check, okay, if the last element that has been inserted in the dq, if it is less than the current coming element, we don't need that element. Okay, because we need to keep this element before this position, right? So we will pop this out, because this element is not going to come anymore in the solution, because the coming element is greater than this. I hope you have understood when I explained it in the explanation part. That's why we are popping it out, then we are pushing it, and then we are checking it. When it is greater than equal to minus 1, we just push the front element of the queue into the answer, and then finally we return the answer, right? So yeah, let's run it. So you see this test case has been accepted, and we will submit this. Yeah, so this has been accepted. So this was a hard level question of Q. I hope the Q data structure is clear now. We have solved 4 questions of Q. We have solved 8 questions of stack, and with this video we have covered stacks and Q. And in the 53rd video we will be starting heaps. Thank you. Jai Chinendra.